Welcome to the Sun today for the 31st of March. This is going to be a somewhat different presentation from normal because I'm going to try to summarize all the activity that occurred in March. March started rather quietly and so it came in like a lamb, but activity picked up towards the end, so it sort of went out like a lion. In this presentation you're going to see a lot more movies and some graphs and data analysis that I do personally, so this is my own research. It's not something you'll see anywhere else. Overall, solar activity was somewhat lower than in February. We had an average sunspot number of about 134. 47 new sunspot regions appeared during the month. Flare activity was lower. We had 113 C flares compared with 239 last month. There was 21 M flares compared with 49. There was one X flare, which is about the same, and about 165 coronal mass ejections, which was somewhat more than in the previous month. Now remember, February only has 28 days and this has 31, so you have to correct these numbers slightly for that. One of the analyses that I regularly do is to track where the average sunspot latitude is as a function of time. This gives me some idea of when solar minimum is going to be. In this plot here we have blue is the northern hemisphere, red is the southern hemisphere, and you can see from the formulae that are here, which is the least squares fit to the data, that the rate of decay of these sunspots towards the equator is actually about the same for the two hemispheres. And they predict that in the northern hemisphere that the spots will reach the equator in about November of 2030, and in the southern hemisphere of September 2030. So those are very similar, which gives me some confidence that we're getting things right. Shows the two hemispheres are getting more in phase with one another, and that solar minimum will be around the middle of 2030. So this is going to be a fairly normal decay of a solar cycle. So there's nothing going to be dramatic going on unless there's a sudden drop in the latitudes of these sunspots, but there's no sign of that as yet. Another important parameter for the sun is the so-called smooth sunspot number. This is a sunspot number that takes the last 13 months and averages them. So at the moment our latest data point is in September of 2024, i.e. 6 months ago, and that was at 159.3 for the average sunspot number. Now that is up over 2.6 points from the previous month. So the smooth sunspot number is continuing to rise. It's at its highest point so far this cycle, and it's that number that determines when the maximum will be. So the very earliest that the maximum could be from this cycle is September of 2024. And I think it's likely that this is going to carry on going up for at least a month or two as yet. We want to watch that number start to go flatten out and go down before we could say we're at solar maximum. Now I'll remind you that my prediction back in 2020 for the peak of this cycle was 165. So I'm feeling really very good about this cycle as far as predicting it is concerned. And that would be the second cycle in a row that I got the number about right. The sunspot numbers varied quite a lot throughout March. So I'm going to show you a 28-day movie of the white light image from the SDO HMI instrument. That's the photospheric level of the sun, and you will note that there's a sudden drop-off in sunspots near the middle of the clip, and then towards the end larger regions start developing in the last few days of the month. Now that gives me some hope that April will be more active than March. Another thing that seems to have changed quite considerably over the last couple of months is that coronal holes seem to be becoming more prominent. So I'm going to show you a 28-day one rotation movie of the Solar Dynamics Observatory AIA 211 angstrom movie. That's a corona emission at about 2 million degrees. The coronal holes are the dark areas, and as they're becoming more prominent and larger as time goes by. So this is worth keeping an eye on over the next few months. There is little sign of polar coronal holes as yet. Next, we'll take a look at the transition region, which has been quite active. Again, a one rotation movie from the SDO helium-2 304 channel. It's cool plasma, or relatively cool plasma, at about 50,000 degrees Kelvin, and that sits between the cool photosphere and the hot corona, hence called the transition region. Now here you're really looking for eruptions of filaments and prominences, and so this is sort of a fun channel for seeing the origins of coronal mass ejections. We can actually see those eruptions of prominences and filaments through the CMEs you see from the coronagraphs. And so we're going to go to a different instrument, the SOHO LASCO C2 and C3 coronagraphs, and look at the outer corona and show that it's still quite active. Note the change in the SOHO orientation near the beginning of the series and the drop in image quality as a result. And the reason for that change in orientation is to improve the communications between Earth and the spacecraft. Big flares were pretty scarce in March. We're going to look at the AIA 94 angstrom channel, which is about 5 to 6 million degrees Kelvin, and mostly C flares and low M flares. There was just one X flare towards the end of the movie. See if you can catch it. It's on the southeast limb. Can we use the flare rate to determine the date of maximum? So here's a block plot of C flares for each year throughout the cycle, and that produces a curve which, if you look at the peak of, you could interpret as an idea of the date of maximum. However, if you look at this plot as it stands now, that would predict June of 2024, and we know that's already wrong because the data from the smooth sunspot number indicates that the earliest date that maximum can occur is in September. So that would imply that we're going to get a lot more C flares in the rest of this cycle. As we only got into 3 months into 2025, the statistics on that last channel are quite poor. We can do the M flares and X flares in a similar way. They both indicate September of 2024, so that would say that this last month here is the last month of rising smooth sunspot numbers. We'll see next month whether that's true or not. You can see that the coronal mass ejection rate is still climbing and still outperforming solar cycle 24 quite considerably. So I think it's safe to say that solar cycle 25 is still surging ahead and has not shown any sign of decaying yet. Well, let's draw some conclusions. Solar cycle 25 is not slowing down as yet. We're not at maximum. Sunspot migration towards the equator looks normal and indicates that solar minimum will be something like in late 2030 or so. Maximum may have already happened late in 2024. However, we won't know for about 6 to 10 months whether that's in fact the case. And there's still no sign, for those of you hoping for a grand solar minimum, of that appearing. So I think that's a dead loss. And we have some breaking news. Just as I looked to put this video together, I saw that there was a weak radiation storm in progress, an S1 level storm, which means the 10 MeV warning threshold has been exceeded. So we're being bombarded by high energy protons, and it is causing considerable difficulties with radio communications in the polar regions, as can be seen in the bottom right here, that most of the radio emissions below 6 megahertz are being absorbed out entirely from the radio spectrum. So communications there are going to be very difficult. This will hamper transpolar flights, for example. Once again, thank you for listening. If you enjoy these videos, please pass them on to friends or neighbors or relations who you think might benefit from understanding more about how the sun works. And so until next time, stay safe and goodbye.